Welcome to queenon7.com. Please like, share, and subscribe my video. Today we're going to look at the reversible reactions. Reversible reaction is a part of the series which I'm actually doing at the moment, rate of reaction, and the factors affecting the rate of reaction. Now, reversible reactions are actually a totally different reaction which you have done before. For example, if you are going to burn a paper, can you reverse the process? Because you are going to produce carbon dioxide and you're going to produce ashes like a pure carbon. You cannot reverse that process. Water and ash, you cannot reverse that process. So some reactions in chemistry are actually in nature, they are actually reversible. Some of them are irreversible, but we are talking about only purely about the reversible reaction. These irreversible reactions are actually written with one arrow. The reversible reactions have got two half arrows, one in the forward direction, one in the backward direction. So for example, if you're making A plus B and converting into C plus D, in this case, half arrow forward and half arrow backward. So this is actually backward reaction. So when we talk about backward reaction or towards the left hand side, the reaction is moving left hand side, it means the reaction is going backward. And this one is actually forward reaction, or means this one is right hand side reaction. One of the very famous actually example is you can actually have a test tube and you can have copper sulfate which is actually blue color. The moment you're going to heat it up, you're going to heat it up, copper sulfate, which is blue color, will be converted into, we normally use the heating basins, but it will convert into a white color. It will be white color. It is still copper sulfate, but the water will be gone into the atmosphere. So what's going to happen here and what happened there? Let's have a look. Copper sulfate with 5 water molecules. Copper sulfate actually, when have 5 water molecules, it is called hydrated. This is one of your practical as well, which you need to look at. Hydrated copper sulfate means copper with water. The moment you are going to actually heat it up, copper sulfate will be left and water will get out. Now this side is actually called, what do you call it as, here you will have anhydrous, and this side is hydrated. So when there's no water, it's anhydrous. Now what happened there is that you have converted blue into white color powder and you have heated up. So this reaction is actually endothermic. So technically in reversible reactions, when you put the energy in, that direction of the reaction is called endothermic. And when you are going to, once you have made copper sulfate just white on its own, suddenly you realize, you know what, I am going to put a drop of water in it. So you are going to put a drops of water. This copper sulfate absorb the water and it will go into the backward direction. So that's gonna be exothermic. The moment you are going to put water in it, the heat will come out. When heat is out, it is exothermic reaction. It's a backward direction. Now you have actually reversed the reaction. So some reactions you can reverse them. You reverse them and look at that the reaction has actually converted back into copper sulfate. Once you're going to put that in, this will be converted into blue color, which means copper sulfate with the 5 water molecules will obtain again. Right. One more example we can do that. The second example is ammonium chloride. NH4Cl, you can still the same thing. You heat it up, you will produce ammonia and chlorine gas. So this is solid. So you have NH4Cl, you heat it up. Once you're going to heat it up, let's just say you have a rubber bung there and you stop those gases from escaping. They will rise here on the top of the test tube and they will make ammonia gas and chlorine gas. And the whole NH4Cl disappeared. But what happened there now, because you have heated up, again, this is endothermic because you have put the energy in. On the top of the tube here, it is actually cold area. This one is obviously heated area. Because this is cold area, those two gases which actually gone in that cold area, they will react together again and they will come back into NH4Cl. Now what's going to happen there is, in this test tube, after the heating up, you will see some of the white powder will be deposited there. A white powder you will see there, which is ammonium chloride, which was actually present in the bottom at the start, and then it's gone and it's actually deposited on the side of the tube. So this is called reversible reactions, and energy wise, the forward reaction is endothermic and the backward reaction is exothermic. Means energy, you're going to put it in, and here energy will come out. All right, thank you very much.